Managing the cost of healthcare is a battle being waged on many fronts. Heating and cooling typically account for 50 to 60% of a hospital's annual energy costs. Chilled beam technology leverages the energy density of water to more efficiently deliver heating and cooling compared to all air systems. Two hospital projects on opposite sides of the globe benefited from chilled beam technology. They also benefited from each other. In 2004, affiliated engineers recognized the potential of chilled beam technology to dramatically improve the performance of energy-intensive buildings. The firm used computational fluid dynamics analysis and full-sized mock-ups in extensive verification testing. AEI then pioneered the first large-scale use of chilled beams in a U.S. research lab. AEI began work on the Kaiserslautern Military Community Medical Center in 2010.
So we started on a 1 million square foot inpatient care center and outpatient care center in Kaiserslautern, Germany, with Department of Defense, US, and German energy efficiency goals. And one of the technologies explored early on was active chill beams. It's a very energy efficient way of conveying heating and cooling to a clinical environment. From a German perspective, this was old hat. This was standard. They've been doing this for years, didn't understand what the fuss was about. On the other side of the ocean, this was all new to us and to the client.
AEI executed new CFD modeling on behalf of the Department of Defense. AEI was also working on a new bed tower for Cone Health Systems. This would be the first use of chilled beams in patient rooms in the United States. When budget sequestration stopped work on Kaiserslautern, Cone took up further CFD modeling. Cone opened the 96-bed tower in 2014, performing exactly as AEI Energy Modeling had predicted. Within a year, another AEI bed tower project with chilled beams opened in the U.S., the first such use of the technology in a hospital renovation. The Kaiserslautern project resumed in 2015, renamed the Rhine Ordnance Barracks Medical Center Replacement.
So when Rhine Ordnance Barracks resumed, we had the benefit of two projects, Cone Health and St. Elizabeth Hospital, that now provided data, real performance data, clinical outcomes to help inform the project with the Department of Defense. And so we were able to take that performance data, in addition to the fact that both those projects were in more extreme climates, both from a heating and a cooling perspective, we were able to show that we can meet comfort requirements, we can meet clinical requirements with a chill beam in a care setting in Germany. So one of my favorite things about chilled beams is they allow us to work in a lot less space. So new construction, it's great. You can save maybe a 6 inches to a foot of floor-to-floor height. But there are a lot of old clinical facilities in the United States that don't meet modern healthcare requirements for airflow and ventilation, and they literally can't squeeze that much technology into those small spaces anymore. A chill beam, being a much more compact way of delivering heating and cooling, allows a lot of old infrastructure to be reused. So the example would being St. Elizabeth Hospital did a renovation for 10, 12 patient rooms where those were 11-foot floor-to-floor heights, and those continue today as an operation as a clinical space rather than being relegated to being offices or storage or being demolished.